Assalamu alaikum. My name Hakam Mohanna. Inshallah, today we're talking about the solid state dosimeter presented by group 15.
These are the members of group 15.
We have in this show 6 sections. I will start with the introduction. We're talking about the solid state dosimeter. For the second section, we're talking about the work principle for the solid state dosimeter with Noor. For the third section, we're talking about the properties for the solid state dosimeter with Lama. And for the section 4 and the 5, talking about the application and advantage and disadvantage for the solid state dosimeter with Ra'id. For the final section, we're talking about when and why the solid state dosimeter is preferred compared to other dosimetry system with me and Lama. I will begin with the first part, which is the introduction. Now we will start in introduction. Firstly, we should know what is the dosimetry. Very important to know what is the dosimetry. The dosimetry is the science of quantifying and assessing the observed dose of ionizing radiation in biological and non-biological material. The pyramid goal we should know from the observed dose when use ionizing radiation in biological and non-biological, that to ensure the safe use of the radiation in the different fields such as the medicine, industry and research, and the traditional dosimeter like the film pages and the thermoinstance dosimeters. This dosimeter have been instrumental in the monitoring radiation exposure over the years. Now we're talking about the solid states dosimeter. The solid states dosimeter is presented as the revelation shift in a radiation monitoring technology, as the traditional dosimeter that really on the chemical change. The solid states dosimeter, it's used the semiconductor material. The semiconductor material like silicon or the lithium fluoride. This semiconductor include by respond the ionizing radiation. This ionizing radiation get by generating electron hole pair and resulting electrical charge. Okay, and we have the relationship between the radiation dose and the electrical charge. This is the relationship is the proportional to the radiation dose. This semiconductor based on the mechanism that's be allowed to real time and continuous monitoring of the radiation exposure. We see from this picture the example for the solid states dosimeter. That's one name, personal solid state dosimeter. Now we continue with the type of the solid state dosimeter. That's the solid state dosimeter have many types, like silicon diode that we use in the medical setting. The function of that type of the solid state dosimeter in medical setting give accurate and real-time monitoring of the patient dose during diagnostic imaging or the radiation therapy. The another type that we should know, the lithium fluoride, are this type they commonly used in the environmental and industrial monitoring. There the ability to the coverage a wide range of the radiation type. This type of the solid state dosimeter emerging technology may be introduced a new type of the solid state dosimeter. This picture, for example, the type of the solid state dosimeter. Okay. We continue with the type of the solid state dosimeter. We see from this table give the summary of the solid state dosimetry system types and the principle of the operation. The first one and the second one we talking about in the previous page. But now we're talking about the deep of the principle of the operation in this two type. The first one, the silicon diode. We use the semiconductor ionization, generation of the electron hole pair in the silicon. And for the second one, the lithium fluoride, that's one the thermally sensitive defect include in the lithium fluoride crystal lattice by radiation. The third one, metal oxide semiconductor field affect the transistor. That's one modulation of the electrical field and the semiconductor by incident electron. The fourth one, optically stimulate luminescence. That's the principle of the operation of this type to the trapping of electron in the crystal structure, release as the luminance upon light exposure. The last one, diamond radiation, that's the principle of the operation include change in the cynetic diamond crystal lattice. We should know about the solid state dosimeter advancements, that the mentalization. What is the mentalization? The mentalization, it's that ongoing effect focus in the developing smaller and more portable solid state dosimeter, enhancing their usability in the virus application. The interaction with the electronics. Some solid state dosimeters are designed to interface with the electronic device for the real-time monitoring and data storage. We should know very important thing. The most common function for the solid states dosimeter give the reliability and visibility, play a significant role in monitoring and managing radiation exposure. Solid state dosimeter advancements.
Hi, I am Shuhada and I will continue the presentation with the working principle of solid-state dosimeter. The picture shows are the working principle of solid-state dosimeter in diagram form. This slide will show the flow of working principle of solid-state dosimeter. Solid-state dosimeter uses semiconductor materials such as silicon or germanium crystal. As ionizing radiation passes through the device, P-N junction will be created in the semiconductor material and will generate current pulse. The absorption of ionizing radiation will generate electron hole pairs in the semiconductor. The transfer of energy from charged particle or photon to the valence may raise it through forbidden band to excitant or conduction band. The vacancy left is known as electron hole. The newly generated electron and holes move through the semiconductor due to the existing electric field. The movement generates temporary electric charge. The pulse are then amplified by the preamplifier. The electronic pulse will be amplified by increasing the signal-to-noise ratio. The signals are then recorded and analyzed. Next, my friend Lama will continue the presentation regarding dosimetric properties of solid-state dosimeter.
Properties of solid-state dosimeters. Dosimetric characteristics of solid-state dosimeters make them useful for measuring and monitoring ionizing radiation. These characteristics contribute to their effectiveness and dependability in a variety of applications. Here are some of the most important dosimetric properties of solid-state dosimeter. Linearity. Solid-state dosimeters frequently respond linearly to ionizing radiation doses. This indicates that absorbed dose is directly proportional to the measured signal. But beyond a certain dose range, a nonlinearity sets in. The linearity range and the nonlinearity behavior depend on the type of dosimeter and its physical characteristics. Two typical examples of response characteristics of dosimetry system are sketched in this figure. Curve A first exhibit linearity with dose, then a supralinear behavior, and finally saturation. But curve B first exhibits linearity and then saturation at high doses. In general, a nonlinear behavior should be corrected for. A dosimeter and its reader may both exhibit nonlinear characteristics, but their combined effect could produce linearity over a wide range. Second property is the high spatial resolution. The high spatial resolution of solid-state detectors make it possible to precisely localize the radiation dose. Because the dose is a point quantity, the dosimeter should allow the determination of the dose from a very small volume. This feature is especially helpful in applications such as medical radiation therapy. Low energy dependence. The response of a dosimetry system is generally a function of radiation beam quality, which means energy. But compared to a certain other types of detectors, solid-state detectors typically exhibit a relatively low dependence of the energy of the incident radiation. Because of this, they are adaptable and appropriate for a variety of radiation kinds and energies. In general, the variation due to the energy dependence should be corrected for. Solid-state detectors are generally sensitive to ionizing radiation, which means that they can detect and respond to low amounts of radiation. Small size and portability. Solid-state detectors are useful for a variety of applications such as radiation protection, environmental monitoring, and medical dosimetry, since they are frequently small and portable. Example is the TLD dosimeter, which comes in a very small dimension. Dose range. Dosimeters have a dose range within which they can give accurate measurements. This range varies based on the type of a dosimeter and the application. Some dosimeters are intended for the use in high-dose situations, whereas others are better suited for low-dose purposes. Temperature dependence. Temperature changes can affect how well some solid dosimeter works. Temperature variation during measurements may require adjustment and calibrations. Dose rate dependence. Some solid-state detectors may exhibit a dependence on the dose rate of the incident radiation, which describes how its response varies with different radiation dose rates. Some dosimeters might display dose rate dependence, which is taken into account during calibration and use. But in reality, dose rate may influence the dosimeter readings, and the appropriate corrections are necessary. Stability and long-term reproducibility. Solid-state detectors are generally stable over time with long-term reproducibility. This stability is important for precise dose measurement over periods of time, especially in medical applications where consistency is critical. Readout mechanism. The readout mechanism is a fundamental aspect of a solid-state dosimeter. It is the dosimeter method of measuring and reporting the total radiation dose. Fading. Some solid-state detector may experience fading, which is the gradual loss of stored charge following radiation exposure. The fading characteristics of the dosimeter have an impact on its ability to maintain accurate dose information over long periods of time. Fading is often more pronounced in TLD. Fading in TLD can be influenced by many factors such as the temperature, storage conditions, and the characteristics of the specific dosimeter material.
We're talking about application for solid-state dosimeter. The first application, medical radiation therapy, precise delivery of therapeutic radiation in cancer treatment. The second application, diagnostic imaging. Get imaging quality in X-ray, CT scan, and fluoroscopy to minimizing exposure. The third application, occupational radiation monitoring, that works in radiation-prone workplace like nuclear planets. Fourth application, environmental radiation monitoring. That means radiation levels in air, water, and soil to detect emissions source. The 5.1 emergency response. The radiation levels in emergency and responders in protective measures. The last one, personal dosimetry, tracks radiation exposure for the one working with ionizing radiation. We see from this picture example for the type application used in the solid state dosimeter. We complete now with another type application for solid state dosimeter. Research facilities safety protects research by monitoring radiation levels in labs using radiation materials. Space exploration. Healthy risk for astronauts by assessing cosmic radiation levels during space missions. Airbus application. That means radiation exposure in high altitude flights for passenger and crew safety. In nuclear power planets, water safety and environmental protection through continuous radiation monitoring. Radiological protection dosimetry. That means maintain safety standards by accurately measuring radiation doses. The last part, research and development, support scientific investigation with precise data on radiation levels in the different experimental setup. We see from this picture example for a nuclear power plant. Now we talking advantage and disadvantage for solid state dosimeter. A first section, advantage for solid state dosimeter. Able to determine air kerma and tube voltage and have value layer and exposure time and output wave form. The second one, reading process is non-destructive and can be read. The third advantage of solid state dosimeter, high sensitivity in small volume. The last advantage of solid state dosimeter, able to store dose reading for a convenient period. The second part of disadvantage for solid state dosimeter. The first one of disadvantage, solid state dosimeters can be sensitive to temperature variation. The second disadvantage, the response of solid state dosimeters can be energy dependent, which means they may not reply assess all types of ionizing radiation equally. Third disadvantage, high radiation dose can lead to saturation effects in some solid state dosimeters. The last disadvantage for solid state dosimeter, the semiconductor materials used in solid state dosimeters may degrade over time, impacting their performance and accuracy. Now we finished application and advantage and disadvantage for solid state dosimeter. Now Hakam and Lama at a last part.
Me and Lama now state our preference and conclusion for the solid state dosimeter.
When and why solid-state dosimeter is preferred compared to other dosimetry systems? When immediate results are essential, solid-state dosimeters offer a real-time monitoring capabilities, providing instant feedback on radiation exposure. In situations where immediate results are crucial, such as in medical procedure or industrial processes, the real-time data from solid-state dosimeters allow for prompt adjustments and intervention. The second characteristic of solid-state dosimeters is that they have high sensitivity in a small volume. They also require no electrical connection. And because of their small size and easy to use, these dosimeters have found widespread use in the field of quality control measurements. They also have high accuracy and reproducibility, as well as a response that is independent of radiation energy.
Thank you, Lama, for explaining when and why solid-state dosimeter is preferred compared to the other dosimetry system. The conclusion: the solid-state dosimeter are preferred when real-time monitoring have high sensitivity and versatility and long-term stability and probability, also energy efficiency, and reduce environmental impact and potential advancement are critical factor for the particular dosimetry application. The specific choice depends on the requirements of the situation and the advantage offered by the solid-state technology. Finally, thank you, my friend, and thank you for listening.
These are the list of preferences that we have used for our presentations.